What's up, everybody? Mr. Cully here, and today I'm going to take you through a lab that we are doing in class to kind of kick us off on a new unit. This one's going to be about thermal energy and heat and temperature and all that kind of good stuff. So we're slowly moving away from chemistry kind of into physics, and this is kind of a good unit to do that. So I want you guys to be as much of a part of this lab as possible. I know you can't be here, but let's just kind of try to simulate it, and I'm going to show you, kind of go through it with you so that you can follow along, that you know what is going on in class and so forth. All right. So we are doing this lab called the Heat Transfer Lab, and I've got Charizard there because Charizard should always be in the conversation with heat. If you don't know who Charizard is, then I don't know if you should watch the rest of this video. But heat is the transfer of thermal energy. Okay, we talked a little bit about heat back in the previous unit about exothermic and endothermic reactions. Heat is the transfer of thermal energy from one object to another. We talked about that. We talked about endothermic is where it takes energy from the surroundings, and exothermic is where it releases it to the surroundings. So we're talking about energy transfer. What is energy? Remember, I kind of talked about how molecules, if you give them sugar, then they get really excited. That's the energy we're talking about. Thermal energy is just pretty much how excited molecules are, how fast they're moving in a sense, the energy that they have. And we also talked about how it flows, this energy flows from hot to cold. Okay, so we're talking about these different terms: heat, thermal energy, temperature, but they're all going to kind of come together, and we're going to explain how each of them are different. All right, so let's get into a prediction first. Let's get into a prediction first. So in this lab, we're going to be mixing water. It doesn't sound that fun because it's just water, but I want you guys to think about this. Let's say that we got two beakers, okay, and we got equal amounts of water in each, but they're different temperatures. Let's say that one's 10 degrees, so that's a little bit above freezing, okay, a little bit above freezing, actually kind of a good amount above freezing, but anyway, just imagine it as kind of cold, all right, kind of cold water. And then 90 degrees Celsius water, that's almost boiling, like that's going to burn you if it's going to touch your skin. So you got this cooler water, and then you got this really, really hot water, equal amounts of both. What would happen if you mix those two together in a third beaker? Okay, you got an empty third beaker, you mix the two together, and then you took the temperature. What do you think that final temperature is going to be? Once you mix it all together, you have equal amounts of both, but one's at 10 degrees, one's at 90 degrees, you mix them together. What temperature do you think it's going to be? Prediction one. Doesn't have to be right, just whatever your prediction is. All right, number two, what if you were to mix 10 degrees Celsius water with double the amount of 90 degrees Celsius water? So imagine you've got a big beaker, okay, a large beaker, double the amount of water, of hot water, than you do the cold water, and then you mix them together. Is that going to affect the final temperature? So what do you think it's going to be if you have a big beaker of hot water and a small beaker of cold water, and then you mix them together? What would the final temperature be? All right, so those are the two predictions that we are going to be discussing. And then in this lab, what we're going to have is we're going to have a warm water supply and a cold water supply. And I'm going to take you through how we go about getting this warm water supply. So every lab station's got what's called a hot plate. I don't know if you use these in middle school or not, but a hot plate is just going to be a plate that gets really hot. It's metallic. It plugs into the outlet and it gets super hot. But basically, we're going to fill a beaker up with 500 milliliters of warm tap water. We're going to place it on this hot plate. We're going to turn on the hot plate, and we're going to allow that water to boil. So that's just where we get the warm tap water from. That's the hot plate itself. We're putting the beaker of 500 milliliters of water on it, and we're turning that thing, cranking that thing up all the way. All right. So what I like to do is, because I associate hot with red, I'm going to put some red food coloring in just to know that this is the hot water. Okay. It's also a safety thing. You know exactly that it's going to be hot water. Also, if you were in class, you'd be wearing goggles too, because we don't want hot water in our eyes. So yeah, we got that. We're waiting for it to cook. And now it's starting to boil. So we're just going to kind of leave it there. That is our hot water supply that we're going to be using here in a second. All right, we need a cold water supply. So good thing it's wintertime. I went out, got some snow. I got this big bin of snow. And what we're going to do is we're going to put a scoop or two or three of snow inside a beaker. We're going to fill that beaker with some cold water. And then we're just going to kind of mix it until all the snow melts. So we get about 500 milliliters of this. So now we got this super cold water, and I also associate cold water with blue. You know, it's just a thing. So I dye that blue just because it makes it easier in my mind to know which one is which. So we got these two supplies. We got hot water that's sitting on the hot plate that's boiling. We got our cold water that just came from snow. And now we have our two supplies that we can pull from. All right. So what we're going to do, the first step in this lab, the first trial in a sense, is we are going to measure out equal amounts of both types of or both temperatures of water. So in one beaker, we're going to have 150 milliliters of hot water, and another beaker, we're going to have 150 milliliters of cold water. All right. So we have a data table. In this data table, we're going to fill it out as we go. So the first trial is going to be the first row. That's what we're working with right now. So I just said we're measuring out 150 milliliters of hot and 150 milliliters of cold. So on your data table, what you're going to do is where it says volume, that's how much water we're using. Under the cold water, what we're using is 150 milliliters. Same thing with the hot water. We're using equal amounts of both. So in that first row for this first trial, we're using 150 milliliters of cool water, 150 milliliters of hot water. Good to go. All right. So there's our cold water, 150. And when we're dealing with hot water, you got to use proper equipment. So goggles, obviously, got to use gloves, both hands. This is one hand because I had to take a picture, but use both hands. And then get 150 milliliters of hot water. Okay. Next step, what you're going to do is you're going to quickly take the temperature of both of these. All right. So the cold water is about 7.3 degrees Celsius. That's pretty chilly. All right. So let's write that down. 7.3 degrees Celsius. Cool water, boom, got it good. Our hot water, 85.4 degrees Celsius. That's almost boiling. That's pretty hot, okay? So we are going to be putting that in our data table as well. All right, so now we have our cold water, hot water temperatures. And now what we're going to do is we're going to mix them together, equal amounts. This is the entertaining step. So we're mixing our hot water and our cold water in an empty beaker together. You can see the colors kind of mix. But what temperature are they going to land at? That's the question. One was about 7, one was about 85. And that's where they land, about 42.2 degrees Celsius. So what's our final temperature after we mix them? Well, 42.2 degrees Celsius. So the cold water was 7.3, the hot water was 85.4, and we used equal amounts of both. We poured them together, and they landed at this temperature. Is that what we thought? Well, let's take this a step further. How much did the cold water raise in temperature? Well, the cold water was at 7.3 degrees, right? And it rose to 42.2. So if we want to know how much it rose, you got to take that final temperature, that 42.2, minus 7.3 degrees Celsius. That's exactly what we're going to do. So I put the work in there so that we can understand where we're getting that number from. But if you take the final temperature of the water, the 42.2, minus the cool water, the temperature of the cold water, that's how much temperature, that's the temperature that the cold water rose. All right. It rose to 34.9 degrees once you mix the two together. Well, how much did the hot water drop then? Well, the hot water was at 85.4 degrees Celsius. It dropped down to 42.2 degrees Celsius, just like the cold water warmed up to 42.2 degrees Celsius. So how much did it drop? Well, you take your hot water temperature minus your final temperature, which was the 42.2, and you get 43.2 degrees Celsius. All right, fair enough. So our cold water rose by almost 35 degrees. Our hot water dropped by about 43 degrees. Interesting, okay? Well, that's kind of what we're looking at here. We're going to be discussing this. What are our findings? Why would it drop? Why would it rise? And why would it be these numbers? All right, so that's the first trial. Second trial, what we're doing is the exact same thing, except instead of equal amounts of both, we're actually going to use less cold water this time. So before we used 150 milliliters of cold water, now we're using only 100 milliliters of cold water. How would that affect the final temperature? Well, let's take a look. This time we're using 100 milliliters of cold, 150 of hot. Again, you take the temperature, because why are we taking the temperature again? Well, it's going to change. The temperature is going to change. Why so? Good question. All right. And you can see the temperature definitely changed of the hot one, 74.1 degrees Celsius. Why did it change? All right. But anyway, we're going to do the exact same thing. We're going to mix the hot with the cold. And we're going to see where they land. About 44.5 degrees. Okay. So again, what you're going to do in your data table is the exact same thing. You're going to, like we just did, put in your volume amounts, put in your initial temperature amounts, put in your final, and do the work for the temperature rise and temperature drop. I'm not going to do that part for you. I did the first row for you. Okay, so we're doing the exact same thing. All right. Do this for the second row as well. And then for the third trial, what we're doing is we're using even less cold water. So instead of 100 milliliters in the second trial, now we're using 50 milliliters of cold water. So 50 milliliters of cold water with the exact same amount of hot water we've been using the entire time. And we're going to take the temperatures again, okay? So the cold water is 10.9 degrees, and the hot water is 60.6 degrees. And we're going to do the exact same thing again. We're going to mix them. So we got our hot water, and we're going to add the cold water. And we're going to see where it lands. $44.8 about. Okay, so that's where it lands right there. So that's all three trials. What we're going to do is we're to take this data, we're to discuss it as a class, and then on the back, there's post-lab questions. We're going to discuss these together. All right, I want you to try them, but we're to discuss them together, and then you can answer them, and then we'll submit the lab all at the same time. So don't worry about submitting until we discuss the post-lab questions. But I want you to at least get this video and understand kind of the experiment that we're doing and get your data in so that we can discuss it. All right, if you have any questions, please let me know.